Hi, everyone. Let's wait another few minutes if anyone else is joining. Okay, let's get started. 71 is correct. It looks like one of the names is iPhone. Who is that? Do you want to explain?
I did 128 in percent of 25, and I got 32. And then I did the percent again, 25% of 32, and I got 8. I mean, I got
Okay. So first we did 25% of 128, and we got 32. So that means he sold 32 apples to Jill. And so if he sold 32 apples, then that means he has 96 left. And then it says next he sold 25% of those remaining to June. So he sold 24 apples to June, which means he has 72 apples left. And then he gave one shiny apple to his teacher. So then you would do 72 minus 1 is 71 apples left.
Good. So yeah, we start off with 128. 25% of that is 32. So 32 apples were sold to Jill. Then 96 are left. And of those, 25% remaining are sold to June. So 25% of 96 is 24. Subtract 24 from 96, we have 72. And one apple is given to the teacher. So 72 minus 1 is 71. Any questions on this? Okay, let's move to the second one. Okay, so I actually don't see the right answer, but I think maybe your answer is the fourth largest. So why don't you explain how you got that?
Oh, okay. So, I mean, I did the first largest is itself. We were given that. So the second largest is 1,007,000 because I just divided 2,014,000 by 2. So then if you continue that pattern, I thought the fifth largest would be 2,014,000 divided by 5. But if that's the fourth largest, then the fifth largest has to be 2,014,000 divided by 6.
Okay, good. So you're on the right track. But one thing you have to be careful of here. So okay, so divided by 1 is itself, right? So that's fine. Divided by 2, you're right, is 1,007,000. Now so in your pattern, the third one would be 2,014,000 divided by 3. Is this an integer or not?
No, it's not. It's 0.33333.
Good, yes. And how do you know that?
Because it can't go into 0 or 10, I guess how I thought of it.
So that's not always true, right? Because so think about if I had 300 divided by 3, this ends in 0,
Yeah.
0, right?
I mean, like the 1,000 at the end.
Yeah, so well, you could do the same thing with 3,000, right? So how do we know for sure that it's not divisible by 3? Does that make sense, the question? Or like why, how do you know this ends in, you're right, it does end in 0.333, or it's not a multiple of 3, but is there any other way of checking that?
I know there was a division rule for 3. It was like if you add all the numbers up and divide it by 3, I think, and if it divides by 3 evenly, then it'll be so then it's 7 divided by 3 does not go evenly.
Good, yeah, exactly. So 2014, if I add up the digits here, I get 4 plus 2 plus 1, which is 7, which is not a multiple of 3. So I know that this whole number is not a multiple of 3. So 3 itself doesn't divide this, right? So that means that this is not going to give me an integer, so it's not going to be a divisor of 2,014,000, right? I'm not only being integers as divisors, right? So I can just kind of eliminate this. I can move to the next one, which is divide by 4. This does divide it. Actually, we don't even care what it is because we know there'll be some integer here. And how do I know for sure that this is divisible by 4? So in other words, what is a divisibility test for 4? If I give you any number, how do you check it's divisible by 4?
The last 2 digits are divisible by 4.
Good. So I can always take the last 2 digits and check. So in this case, last 2 digits are just 0, 0, which is divisible by 4. So it would be 0, 0, 0, 4, 0, 8. It's 4 times 0, right? So this is divisible by 4. So I know I will get a value there. It's whatever, 500,000, 503,500, something like that. I can write it here. Okay, so now what is the next one? 22,014,000 divided by 5.
The divisibility rule is if it ends in 0 and 5, or 5, it's divisible, so it is.
Good. Okay, so and that would give the fourth largest what you had, which is 402,800. Now, what about the next one? Can I divide by 6?
No, we can't, because the divided by 6 is just if the test for 2 and 3 work, and 2, yes, it is even, but 3 again, 3 again, it doesn't divide by 3. It's 7 divided by 3, so that doesn't end well. So 6 is not going to end in an integer.
Good, exactly. So let's try the next one, 7. Does this divide 7?
7 is I think it's the harder one. It's when you remove the last digit, so 0, and then you double it, which is again 0, and then you subtract the leftover. So
there is a divisibility rule, yeah, you're right, for 7, although I think here it might be fine to just, let's think about, so can we just forget about the zeros? Because we know 100, any power of 10 is not divisible by 7, so just think about is 2014 divisible by 7? This is easier to think about without the rules. So what's the closest multiple of 7 to 2014? Or what's an easy multiple of 7 near 2014?
it's like approximately 287.
Okay, good. So let's say around 300, right? So 300 times 7 is 2100, right? So I know 2100 is a multiple of 7. If 2014 is also a multiple of 7, then the difference between these two should be a multiple of 7, right? So how far is 2014 from 2100? What's the difference between the two?
986.
The last 2 digits is correct.
86.
Yeah, 86, yeah. Now, is 86 divisible by 7?
It's approximately like 12.
Yep, but not exactly, right? So 86 is
Yeah.
not a multiple of 7. So this means that 2014 is not a multiple of 7. The reason is because if 2100 is a multiple of 7 and 2014 were multiples of 7, then the difference also had to be a multiple of 7. Does that make sense?
Yeah.
Okay, so this is another way of checking since the divisibility rule for 7 is not as kind of straightforward. So now let's move to 8. Is this number divisible by 8?
Well, the divisibility rule for 8 is the last 3 digits is divisible by 8. So it is.
And in this case, is it divisible?
Yep.
Okay, good. So what is this 22,014,000 divided by 8? So one way of thinking about this division, let's think about splitting 2,014,000 as 2 million plus 14,000 divided by 8. So what is 2 million divided by 8? Or let's start with what's 2 million divided by 4.
Oh, well, divided by 8 is 2,500, or sorry, 250,000.
Good. 250,000. Now, what is 14,000 divided by 8?
1750.
1750. So what is this?
251750.
So what's the answer?
251,750.
Good. Yep. So we saw the largest is 2,014,000. Second largest is 1,007,000. Third largest, fourth largest, and fifth largest is 251,750. Does this make sense?
Yes.
Okay. Now, one way of doing this instead of, so we actually really didn't need to do all these other divisions except for this divided by 8. And the way you could think about this problem instead is if we had first asked you the question instead of fifth largest divisor, cross this out and imagine if the question was asking fifth smallest divisor. If I tell you what the fifth smallest divisor is it easy to find what the fifth largest divisor is? So let's make this easier. Let's take an example. Let's take a number like 32. What are all its divisors in order?
1, 4, or sorry, 1, 2, 4, 8, and then 16, and then 32.
Okay. What do I know about the second smallest divisor and second largest divisor? Is there a relationship between the two?
If you multiply them together, you get the actual number.
Good. So if I take, imagine when I think about the divisors, right? If I take the smallest one and the largest one, the smallest one is always 1, the largest one is always the number itself. The product is always the number, right? Think about the second smallest one. If it's a divisor, when I divide it out, I am leaving something behind, right? So if I divide out the smallest one, I'll get the largest one. If I divide out the second smallest one, I'll get the second largest one, and so on. You can imagine always you can pair up divisors, right? If I divide out by the smallest one, I'll get this one, and so on. And this is true of any number, right? If I take a smaller divisor, it'll pair up with a corresponding larger one until I reach the middle, right, of this list. Does this make sense? So this is true of any number, right? Whatever the divisors are, I can take the smallest values in order and pair them up with the largest divisors, and their products will be the number itself. So now if I told you what the fifth smallest divisor was, how would you find the fifth largest divisor?
You would take 2,014,000 and divide it by the smallest divisor.
Exactly. So the question is actually first just asking us, what is the fifth smallest divisor? So this is basically starting off, let's say, okay, is 1 a divisor? Yes, of course. Is 2 a divisor? Yes, we know it's even. Is 3 a divisor? We check that it's not. Is 4 a divisor? Yes. Is 5 a divisor? 6 and 7 we know aren't. 8 is. So first, the first step should actually just be this. Let's find the fifth smallest one. So don't worry about what is 2,014,000 divided by each of these. We don't actually care what those are. So we know 1, 2, 4, 5, 8 are the 5 smallest divisors. Thus the fifth largest must be 2,014,000 divided by 8. Does that make sense?
Yeah.
Okay, good. Any other questions on this? Okay, let's move to the last one. Okay, this is a harder one. Any ideas or answers on this one? Okay, so let's start off by, let's make this problem simpler. Instead of saying, so finally in the question we know, let me just draw a grid first. Okay, so this is a 4x4 grid. Sorry, it's a bit uneven, but let's just assume this is a 4x4 grid. Now, basically what we know is that when the frog is at a point, it starts at 0, 0. We want to see how many ways it can go here to 4, 4. And at each step, it can do 4 different moves. It could either jump 1 this way, 2 this way, 1 this way, or 2 this way. There's 4 possible moves the frog can make. Okay, so now before we reach this problem, let's start off with, assume it's just 1D. So assume we're just trying to go from here to here, forget the other dimension. So what are the only moves which are relevant then?
Going right once or twice.
Good. Now let's think about how many ways are there to do that. Any ideas of how we could think about that? For now, let's forget about all this and just think about the bottom row. Okay, so let's start even smaller. So what about just the first step? If I just had to go from 0, 0 to 1, 0, how many ways are there to do that?
One.
That's easy, right? I can only jump one way. What about 2?
There are 2 ways.
What are the 2 ways?
Going just 2 to the right and then 1 to the right, 1 to the right.
Good. Now what about 3?
Would there be 5 ways in total?
For 3 or 4?
To get to the end for 4.
Let's see. I think that does look right, but yeah, let's go to 3 first. So how many ways are there for 3?
3.
Why 3? Good.
Well, you can go 1, 2. Like you can jump 1 space, then 2 space, 2
Yep.
space, then space, and then 3 1 spaces.
Good. So basically the 3 options are I can go 1 the first time and then 2 the second time. I can go 2 the first time, 1 the second time, or 1, 1, 1. Okay, good. So there's 3 ways here. Now I want you to get the number of ways for 4, but I want you to use the information of these 3. How would I do that? Any ideas?
Do you add them all up so it's 6 ways?
Close. So let's think about if I needed to, I want to reach here, right? What places could I have come from to reach there in one move?
The second line or the third line?
Right. So I could have either come from here and jumped 2, or I could have come from here and jumped 1. So let's think about all the ways there are to reach here. All the ways to reach here must have ended with either a jump of 2 from here or a 1 from here. Does that give you any ideas of finding the number of ways to reach here?
Can you repeat that, please?
Yeah, so we know that so to reach this point, right? If I had to make the last jump from somewhere to reach here, I could have made it from here or from here. Now, I want you to use this information to find the number of ways to reach here. Now, someone has already said that answer was 5 before, so maybe that'll help as a hint here. But think about all the ways that there are to reach here, right? They must be some set of moves ending with either a jump of 2 from here or a jump of 1 from here.
I was the one who said it was 5 earlier
Okay.
to get to the thingy. So if we were to jump from the second block to the end, you have 2 ways to get to the second block. So that'd be 2 ways because it's just one move. You can't change that.
Yeah.
And then if you were to jump from the 3 block, then there would be 3 moves.
Yep.
So then that would be 2 plus 3 is 5.
Exactly. Yes. So the nice thing here is that it's something like this idea of recursion. If you've seen how Fibonacci numbers work, actually what you'll notice is this is actually a subset of Fibonacci numbers, right? 1, 1, 2, 3, 5. And imagine if you did continue this on and on, you would actually get Fibonacci numbers here. But the idea is kind of a recursion here, because what we're saying is if I want to know the number of ways to reach here, I can take the number of ways to reach here and add it to the number of ways to reach here. Because if I think about the ways to get to this point, I have to either have found some way to reach here first, then there's 2 different ways of reaching here, and then just put a 2 jump at the end of this, or I have to find some way of reaching here and put a 1 jump at the end of this. And note those will be different sets, right? There's no overlap there because one of them ends in a 1 and one of them ends in a 2. And those are the only ways to reach this point. So I can count the number of ways to reach here by adding up the number of ways of reaching these 2 points, because those are the places I can do 1 step to reach this point. Does that make sense?
Yes.
Okay, now let's fill in. So we can actually now apply this idea to get the final answer, but first let's fill in a few others which are easier. So let's also just fill in a value for this kind of the origin itself. So how many ways are there to reach the origin itself?
Would we start from the origin?
Yeah, we're starting from there.
0?
So let's actually just say 1 because it's we're just counting that as one possibility, because you imagine in this way that I'm adding up, right? If I fill in a 1 there, then 1 plus 1 was 2, 1 plus 2 was 3, and so on, right? Because there's one way that I could be at that point to begin with. So that helps me kind of with adding this up forwards. So let's just count this as a 1 to start off with, because this gives us the nice property that 1, 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. Okay, now let's fill in if we only could go upwards. What are the values here? How many ways to get to this, 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 and this?
The first lineup is 1, second lineup is 2, third lineup is 3, and fourth lineup is 5.
Good. So this is 5. This is sorry, this, let me put a different box here. Okay, this is 3. This is 2. This is 1. All right, let's separate this. Okay, that's 3. This is 2. And this is 1. Okay, so now can we start using the same idea to fill in points here? So just before we actually fill in any values, let's say I wanted to find the number of ways to reach here. Which values would I want to add up to get to the value here? If I knew all the other points, the number of ways to get to those. So it's the same idea as what I applied here, right? So why did I add the value at 2 and 3? Because I could jump 2 from here, and I could jump 1 from here, right? So it's basically all the points that can reach the final point in one move. All of those, the number of ways to reach each of those points, plus adding all of them up, gives me the number of ways to reach to this point. So for the final point, what are the locations I want to add up? You can give me the coordinates. Or tell me, like, in relationship to this point, what are the locations that I want here?
So, like, what is the question asking?
Okay, sure. So what we did here, right? To get this 5, we added up 3 and 2, right? So I want to fill in the rest of this grid, but I want to figure out for each of these points, what are the things I need to add up to get to the value that's here? This is a little bit different because now it's not just 1D, right? Here I only could move on the x-axis, right? Now here I can move both upwards and right. So for this point, okay, so 2 of the values I want to add up are this one and this one. Because from here I could jump 2 to the right. From here I could jump 1 to the right. What are the other points I want to include when I add up this sum?
2 and 3 on the y-axis.
Good, yeah. So if I jump down 1 or down 2 on this axis, from each of these points, I could jump 2 and jump 1 to reach this point. Okay, so now using this idea, let's figure out the number of ways to reach each of the points in between. So let's start with this point. How many ways are there to get here?
Yeah. 2,
Why 2? Good.
because you can either go right up or upright.
Good. Yes. Okay, what about the next one to the right of that point? So what about this point? So don't think about it in terms of what are the total number of ways to reach here. Think about what are all the places that I could have been in last to reach this point. So what is with one move I want to reach here? Where could I have started from?
There's 3 places you could have started, or you could have had your last move at. Either 1 up on the y-axis. So 0, 1, you could have started on 1, 1, or you could have started on 2, 0.
Good. So one of these 3 places, right? So what should I do with those 3 values?
Add them.
Correct. So it's basically the number of ways I can reach each of these 3. I know I just have to add the move that I need to reach here. So if I was here, I can jump 2 to the right. If I was here, I could jump 1 to the right. If I was here, I can jump 1 up. So what should the value here be?
5.
Good. Okay, now let's repeat that for the one to the right of that.
10.
Let's see. Good. Yep, 10. And the one to the right of that.
20.
Good, 20. Now again here, that 20 is because, so I could have come here from either this 5, jump 2 to the right, 10, jump 1 to the right, or from this 5 and jump 1 up. So 5 plus 10 plus 5 gives me 20. Okay, now let's fill this next row. What about here?
5.
Good, why 5?
Because 2 plus 2 plus 1 are the 2, and the 1 are the places that the last move could have been at.
Good, so either here, here, or here. So I want to add these up. Okay, what about this point?
14.
Good, why 14?
Because there's 4 different places you could have been last. The 2 and the 5 on in the 0, 2, 1, 1, 2, 2, 0, 2, 1.
Good, any of these 4 places. So this is now the technique I can use for all the remaining ones. As long as there are 4 places that kind of I could have jumped from, I want to sum this one, this one, this one, and this one. Okay, good. So now let's fill in the rest. So this is 14. What about the next one to the right?
32.
Good. Sorry, I'll move these so it's more readable. Okay, what about the next one to the right?
71.
Let's see. Yep, good, correct. Okay, let's fill in the row above. What about next between or to the right of the 3 here?
10.
Good, and why is that?
Because there's 3 possible places the last move could have been at the 3 that your laser's on, and then the 5, and then the 2.
Good. So 10 here. What about the next one to the right of that?
22.
Why 22?
Oh, 32, sorry.
Good, 32 is right. What about the next to the right of that?
84.
Good. To the right of that?
207.
Good, yeah. Okay, we're almost there, last row on the top. What about the next to the, above the 10?
20.
Good. Next to the right of the 20?
71.
Good. To the right of 71?
207.
Good. And what is our final answer?
71 plus 207 plus 207 plus 71.
Good. And what is that?
556.
Good. And that is the correct answer. Okay, does this make sense?
Yep.
Okay, so 556 ways would have been a lot to compute if you actually had to count, okay, what are the number of ways to jump 1 to the right, 2 up, and so on. It might have been easy for this grid, the smaller one, we're up to 14 here, but you can see this actually exponentially increases as you're going up, right? We have almost 556 ways just to go from this 0, 0 to 4, 4, 4. But the trick here is to think about if I knew the smaller values, right? If I knew the number of ways to reach a smaller kind of coordinate, how do I use that to count the number of ways to go to a larger or a farther point? And that's the trick here where you can get this recursion idea of I can reach here by counting the number of ways to reach these other points and adding up those ways. And then it makes it much easier to count the total number of ways. Any questions? Okay, we're a bit over time, but that's it for today's class. We'll see you all next week.
Thank you.
Thank you.